Let's do a small experiment to understand the stress-strain curve. You see this thin steel wire? Let's see how its deformation happens. On the right, you can see the stress versus strain curve of the steel wire. Now, when the steel wire is under continuous tensile stress, as expected, it elongates. Now look at the graph. The elongation is linearly proportional to the applied stress. So this region in the graph is what it is. If the stress, that is the load, is released, what will happen? See there, the steel wire gets back to its original length. Now within this stress limit, the steel wire follows Hooke's law. What it means is the deformation is elastic. Now let's increase the load further. And what do we see? After a certain point, look at the graph. The wire is not following Hooke's law. That is, stress is no longer proportional to the strain. But if you release the stress, the wire still goes back to its original length. The limit of this behavior in stress-strain curve, that is this point, is known as the yield point. Now, if we increase the stress further, the strain will also increase, no doubt, but it will not follow Hooke's law. What it means is, even if there is a very small increase in stress, the deformation will be much more, and the wire will not return to its original length even after we release the stress. So in this range, we can say that the deformation is plastic. And what happens? You increase the stress further, as expected, the wire will ultimately break, and that is the breaking point.